Present in inglese. Um, Hello, my name is Flavia, and I'm a 10th grade student at Vasile Locaci National College. And I will present a concept and a branch of mathematics called game theory that has various applications in real life. We'll start by introducing what is game theory. In most of the cases, we'll analyze people's behavior in competitive situations. And it was first introduced by John von Neumann and his colleague Oskar Morgenstern. And it has various applications in real life, including in biology, computer science, and social sciences. And we will move to a very interesting concept called Nash equilibrium. And as said here, it's an equilibrium. So if we are playing a game, it represents the most stable state. So if Sarah and John are playing a game, they are in Nash equilibrium if Sarah is taking the most optimal decision for her, considering John's decision. And John is considering the most optimal decision for him, considering Sarah's decision. We will see in problems that it's not always the best, it will not always give us the best possible outcomes. Because, for example, if the players could cooperate, they will get a better payoff. And now the most well-known game theory problem called the prisoner's dilemma. And here is the text. So we have two prisoners that were arrested for a crime. And if they opt for silence, each of them will have 1 year prison, will have a 1 year imprisonment time. But if one decides to inform and the other stays silent, the informant will be released and the other prisoner will face a 20-year imprisonment. But if they both choose to inform, a 5-year prison sentence awaits each of them. And we need to see how will each of them proceed. And we have a picture here. So we have prisoner A and prisoner B. So we can see that if they both choose to confess, they will both get 5 years. If one confesses, he is freed, and the other remains silent, he will get 20 years. And if they both remain silent, they will both get 1 year. So let's say I'm prisoner A. The most beneficial outcome for me is to be released, and then to get 1 year, then 5 years, then 20 years. We can ordinate the same pairs for prisoner B. But let's think. I'm prisoner A. I choose to confess. Prisoner B can either choose to confess and get 5 years or 20 years. So he would choose to confess and get 5 years. If I remain silent, prisoner B could either confess and get 0 years or 1 year. So he would again choose to confess. So prisoner B has a dominant strategy of confessing. And we can see that prisoner A will also have a dominant strategy of confessing in the same way. So the Nash equilibrium in this case will occur when both pairs confess and both get 5 years. As I've said earlier, this is not the best possible outcome for them, because if they could cooperate with each other, they could get 1 year or 1 year. But the Nash equilibrium is the most stable state in this case. And now we will move on to a problem. So we have two leading bookstores in Baia Mare called Leaders Heaven and Bookworms Delight that are considering implementing a loyalty card program. If they implement the program, they will offer a 10% discount on every second purchase. And we have here the profits. And the first question is, we have to determine each of the bookstores' dominant strategy. So, if Bookworms Delight decides to implement the loyalty card, we are here. Readers Heaven could either implement it and have a profit of $700 or not implement it and have a profit of $650. So he would choose to implement the loyalty card. If Bookworms Delight decides not to implement the loyalty card, we're here. And Readers Heaven could either make a profit of $820 or $710. So he would choose to implement the loyalty card. So its decision should not be based on what Bookworms Delight would do, and he has a dominant strategy of implementing the loyalty card. Now, if readers haven't decided to implement it, Bookworms Delight could either have a profit of 800 or 750. So he would choose to implement it and have a higher profit. But if readers haven't decided to not implement it, Bookworms Delight could either implement it and have a $600 profit or a $680. So in this case, they would choose to not implement it. So we can see that in the first case, they choose to implement it, and in the second, to not. So they don't have a dominant strategy and should adjust their decisions based on the other bookstore's decision. Now we have to identify the Nash equilibrium and calculate each library's profits. So we have seen earlier that Reader 7 has a dominant strategy of implementing the loyalty card. In this case, Bookworms Delight could either implement it or not, and they would choose to implement it because it offers a higher profit. So the dominant strategy would occur when both bookstores implement the loyalty card, resulting in an $8 profit for Bookworms Delight and a $700 profit for Reader 7. And now, let's say that both decide to implement the loyalty card, and we have to calculate how many purchases a customer needs to exceed the cost of the loyalty card. That's $30, and we know that the price of a book is $15. So we can calculate the discount, and we will see that $1.5 is a discount on every second purchase. We need to make up to exceed the cost of the loyalty card. So to find the purchases, we'll do 30 multiplied by 2 and divided by 1.5. And we will see that the customer needs to make 40 purchases to exceed the cost of the loyalty card. And here I have put some practice problems. You can find more problems in the material that are similar. The first one is also based on another well-known problem called the Battle of Sexes. So we have seen in this presentation that game theory is a very powerful tool that helps us analyze people's behavior. And we have seen that it has applications in economy, when implementing a loyalty card or not. And Nash equilibrium represents the most stable state when choosing a decision based on the other. And we will finish this in an interesting way. So a joke that I found regarding game theory is this. Why did the theorist bring a ladder to the poker game? Because he heard the stakes were high and wanted to reach the Nash equilibrium. Thank you.
Da, mulțumim, Flavia. În mod sigur, nici în limba română nu se studiază teoria jocurilor în liceu. Așa că am avut 3 prezentări foarte extra programei de liceu și vă mulțumesc foarte mult pentru toată această prezentare. Întrebări, dacă avem. Accepți întrebări și în română.
Da.
Sau aprecieri. Dacă nu, mulțumim încă o dată și n-are rost să mă repet din nou pentru partea teoretică aplicată în practică. Am zis mai înainte la cealaltă prezentare și